Okay, we're going to get started with chapter 10, and we are in section 10.1, and it is all about circles. In fact, the whole chapter is about circles. This specific chapter is just a little introductory information about circles and a little bit about circumference, which you already know, so we're not even going to talk about it in this video. You're just going to get to wing it on the assignments, I guess. So we're going to start out with something you already know, but we're going to be a little more specific about it. It's the definition of a circle. A circle is the locus, and that may be a new word for you, but it's one you're going to hear a lot. A locus just means a set. So it's the locus or set of all points in a plane equidistant from a given point, called the center. Okay, so write all that down, and we'll give you a quick idea of what that means. It's the locus or set of all the points in a plane that are equidistant from a given point called the center. So I'm going to start with a little picture. So here's my given point. This is one point. And I can draw another point here, right? Well, the distance between those 2 points, there's another point that's that same distance away, and it might be over here. And there's another point, same distance over here, and there's one over here, and you kind of get the idea that there's a lot of these points. And if we keep getting all of them, eventually they're so close together because there's an infinite number of them. So as we get every single one of them accounted for, all of a sudden we have this circle. And that's not a very good picture because circles are pretty difficult to draw. So I'm going to use a tool to make your circles so that your notes look a lot better. So in a circle, we already said that we have a center. So right here in the middle of this circle is going to be the center. And the letter we're going to use for center most of the time is a C. So that's pretty easy. And you already know that across the middle of this circle, there's a diameter. Right? And you also know that along that diameter, if you cut it in half, there's a radius. Right? So we know the diameter, we know the radius. We're going to go ahead and label these a little bit. So this is going to be point D, and this is going to be point E. We're going to add one more type of segment on here, though. So we know diameter, we know radius, and now we're going to put this random one that goes anywhere you want. It just doesn't go through the center, so it's not a diameter. It's another random segment across this circle. And we're going to mark it, and this is going to be point A and point B. Okay, this segment, this new one that we made, this is called a chord. All right, so we're going to write down real quick a little more fancy definitions of these things. So first we have a radius. So a radius is a segment with the endpoints at the center and on the circle. So if you're not sure what that means, it means the radius is this red little line here, this red little line segment, and its endpoint is on the center and its endpoint is on the circle. So our radius is CE, and also we have the radius CD. Even though it's not marked in our picture, it's still there. All right, now we have a diameter. This is also one we already know, but we're just going to get a little more formal with our definitions. So it's also a segment with the endpoints on the circle, and it goes through the center. So our example is DE. We could also say ED, right? So we know that one. The new one, the new word that we're just learning today or just talking about is a chord. All right, and that is a segment with endpoints on the circle. Now notice I say on the circle, it's not going through the center, but my definition doesn't say not through the center. So a chord in my picture is AB and DE. So even though DE is a diameter, it's also a chord, even though typically when we see chords, they're going to be like AB is. They're not going to go through the center. All right, we're almost done. There's two more things that we need to talk about. And they're words you've heard before, but we're going to do a little more with them. So there's inscribed versus circumscribed. Okay, and a good way to remember is that inscribed is inside and circumscribed is outside. And we're going to draw a couple of pictures and be able to write and say a couple of things that will make our problems a lot easier to do. So we're going to start with a circle. And inside this circle, we're going to put a polygon. I'm going to try to do it nice and neat. All right, so there is our polygon. This is going to be polygon W, X, Y, Z, and this is going to be right inside circle C. And now I'm going to do kind of the opposite. So I'm going to make a circle. And I'm going to make a polygon that goes around it. So we'll see how this goes. All right, not terrible. Not perfect, but not terrible. All right, so let's take a minute and get these pictures. This will be W, X, Y, Z also. And we'll have it going around circle C. And we're going to split this up. We're going to write four little statements. First thing we're going to write is about our polygon WXYZ. And we will say that WXYZ is inscribed in circle C. Or you might see it written like this. A circle with a dot in the center and a C like that. So whichever way you want to write it, you'll see it both ways, but that's just how we say circle C. Okay, and then you also might see circle C is circumscribed. And you could say around or outside of, but the word you'll see is circumscribed about WXYZ. So about just means around. So circumscribed and inscribed. Be able to read them and draw the pictures and be able to see the pictures and write down what you see. All right, so we'll come down here for this one. WXYZ is circumscribed because WXYZ is on the outside about circle C, and circle C is inscribed in WXYZ. Okay, so that's it. Nothing exciting, just a few words, a few ideas. See you tomorrow.